faculty in Associated Faculty in School of Computational and Integrated Science and Associated Faculty in Atal Bihar Vajpayee School of Management and Entrepreneurship at Jawaharlal University, JNU, New Delhi. He has completed his PhD in the area of database from Jawaharlal University. After completing his MPhil and MSc in Operation Research and BSc Honours in Mathematics from University of Delhi, his research interests are database, data warehousing, data mining, machine learning, nature-inspired algorithm, disaster management, big data, and associated analytics. Professor Present is also the international student advisor at JNU, Jawaharlal University. The short list of professors also Professor and Dean School of Computer and System Science. Again, concurrent faculty School of Engineering, Associate Faculty ABVB School of Management Entrepreneurs, and concurrent faculty Special Center of Resource. And finally, the got the great position of internal students advisor from Jawaharlal University. In latest and current any project, professor is given the explain us latest application latest during of. Right now, the handover to the special lectures Professor T.V. Vijay Kumar from JNU. Professor, Professor, Professor.
Yes.
Thank you, Professor. Thank you, Professor.
Okay. So, can you see the slides?
Professor, loading. Yes, right now is visible, Prof.
Yes, sir.
Okay.
Yes, Professor. Yes, Professor.
Okay. So, I think this is the Bharathiar University, isn't it? Yet.
No, Professor. Bharathiar University, Professor.
Bharathiar, sorry. Bharathiar University. Okay. Okay. So, good morning, everybody. Today, I'll be just talking about two aspects. First, in my first talk, I'll be emphasizing on data science and big data. Then I will be emphasizing on computational intelligence and soft computing. That is what I will be emphasizing on. But because see, I'm primarily a background of my graduation and masters in graduation in mathematics, masters in applied mathematics, and then I did my PhD in the area of databases. So I'm right now a professor in computer science, though I'm also associated with the School of Engineering. I'm there also, I teach there also. I'm also associated with Special Center for Disaster Research, so I work on applications of AI in disaster management. I'm also concurrent professor with the Special Center for E-Learning. Also associated with two other schools, Atal Bihari Vajpayee School of Management and Entrepreneurship, and the School of Computational and Integrative Sciences, and also being an international student advisor. So I'll be mainly talking about data science and big data. So something to do with data, and you know why I would like to emphasize the fact that these areas are not something which has suddenly come up. They have evolved over a period of time. So I would like to start from how the databases took place initially, and then how it evolved over a period of time. So when we start with the initial databases were more or less centralized systems where you used to have a mainframe machine which was connected to terminals, which were actually assumed to be dumb terminals. So when we call such terminals as dumb, we mean that they were only had a displaying screen and a keyboard. They did neither had data nor had any processing capability. But you can see from the figure itself that, you know, if only one node is keeping track of the processing and data capability, and if that node fails, the entire system fails. So the major limitation with such systems was there was a central single point failure. Assuming that, you know, we have one node in Delhi, being a capital of India, and which has information about four different cities, major cities of India: Mumbai, Chennai, and Kolkata, and Delhi. So it's like storing all data of Mumbai, Chennai, and Kolkata also in Delhi, in addition to Delhi's data at Delhi. So any queries that take place from Mumbai, Kolkata, and Chennai have to use the communication link to the Delhi server, which carries that data. But if suppose the Delhi server fails, just imagine what may happen. The entire system collapses because no other system has any data or the processing capability. So initial such database systems were developed in a centralized fashion where they had a mainframe. But gradually people realized that it had a very poor reliability because it was a central single point failure. And if that single node fails, the entire system fails. So what they changed was they said that instead of why don't we have, for example, in the case of Delhi, Chennai, Kolkata, and Mumbai, why don't we store Delhi's data at Delhi, Chennai's data at Chennai, Kolkata's data at Kolkata, and Mumbai's data at Mumbai? Now that would lead to something like a distributed database system, where each data is stored in their own server and they are connected through a network. The network is used when somebody at Delhi wants to access data at Mumbai because the data resides at Mumbai. Now this immediately addresses the limitation of a centralized system because even if the Delhi server fails, the other three systems are still working. So the entire system never goes down here. And later on, in order to improve the availability, there is one thing called reliability. The reliability improved, but further to improve the availability, that at any point of time, even if the original node containing data fails, there's another node containing the same data. They started replicating the information. So replication means that Delhi data was at Delhi. Along with that, it was also in Mumbai. Similarly, Mumbai data at Mumbai. Along with that, it was also in Chennai. Chennai data at Chennai. Along with that, it was also in Kolkata. Kolkata data at Kolkata. Along with it was there in Delhi. So in that case, even if the Delhi data fails, if Delhi server fails, the data still resides in Mumbai. And anybody can access that data. So in this case, the reliability and reliability further improves. That even if the original node fails, there's another node carrying the same data. So the idea was to improve the reliability of systems. So they try to move from centralized system to distributed system. But here the distributed systems are made in a top-down fashion. Like if there would have been a field, say city, which had four values, say Delhi, Mumbai, Kolkata, and Chennai. So you use a where clause in an SQL and distribute the data according to where city is equal to Delhi at Delhi, where city is equal to Mumbai at Mumbai, where city is equal to Kolkata at Kolkata, where city is equal to Chennai at Chennai. So it was done in a top-down fashion. It was based on what you call is the horizontal fragmentation. Then later on, in today's with the advent of web, which has come over a period of time, the things have changed altogether. The things have changed. Now, what the things have changed is that now instead of having a top-down fashion, now things have become in a bottom-up fashion. Now things can be integrated, but the only change between a top-down and a bottom-up system is that in a top-down fashion, the things are already there and they are being distributed to multiple sources. Whereas in a bottom-up fashion, what is happening is already there are existing systems which are independently designed. They are autonomous systems. They are independently designed. So when you have independently designed systems, it's so difficult to integrate those systems. So integration of independent design system is very important. So we talk about the next level, which is called the data integration, which comes into picture when we use, in today's scenario, integrating database in a bottom-up approach. Now coming to this situation, let me give you an example. Suppose it's like integrating two systems which are independently designed. So when you know that there are two systems which are independently designed, the database, the language, the database, relational database management system used may be different. They may have a different schema structure. They may have syntactic heterogeneity. They may have semantic heterogeneity. For example, let us see a very analogy to this. Suppose a Chinese and a Japanese would like to have a meeting. So both come to a place to have a meeting. But somehow Chinese knows Chinese, but definitely does not know Japanese. And similarly, Japanese knows Japanese, but does not know Chinese. But then they cannot interact. They cannot have a meeting. Why? They cannot have a meeting because the Chinese cannot interact in Japanese, and Japanese cannot interact in Chinese. So they are not going to have a meeting. So how will they meet then in that scenario? In that meet, they cannot meet unless the Chinese learn Japanese or a Japanese learn Chinese or both learn English and interact with each other. So if you see this diagram, you have the component schema, which is a local schema in one, say site 1 is in Chinese and site 2 is in Japanese. They cannot have interaction. So you transform the local schema. So let us assume that both decided to learn English rather than each other's language. Now both decided to learn English. So what has happened is now the local schema in Chinese got translated into a schema in English, component schema in English. The same thing, information. Similarly, local schema in Japanese got translated into component schema in Japanese. Now at the component level, they have the same language. That is, they can interact with each other now, language. Now the second thing comes is that both have autonomy. When I say autonomy, they would decide what they would like to share and what they won't like to share. They may be carrying a lot of information, but while meeting, they would share only what they were willing to share with the other. So the component schema has further got, component schema in English have got further filtered out into export schema containing the information that they are willing to share. So now both have their export schemas. The Chinese have their export schemas, the Japanese have their export schemas. That means the schema is in English and that carries only information that they are willing to share. Now the meeting takes place. Based on the meetings, they come across what you call the federated schema. Now they interact, they come out with certain documents. In one meeting, they come with one federated schema, in another meeting, they come with another federated schema. That they come out with a document, which are maybe the minutes of the meeting. Now, these minutes may talk about various aspects. This may talk about the operations. This may talk about the healthcare. This may talk about the association in terms of in agriculture. So what happens is this federated schema is a document carrying the information after interaction between two export schemas. And then this document is further being given to the respective departments. Anything related to agriculture, which has been discussed and decided, gives to the agriculture department. Anything that is to deal with healthcare has been given to healthcare department. That comprises the external schema. Now you can see, we know that in the case of centralized database system, it is a 3-level ANSI Spark architecture. Now this becomes 5-level ANSI Spark, 5-level architecture in the case of distributed database system. What are these 5 levels? The 5 levels are the local schema, the component schema, the export schema, the federated schema, and the external schema. So the analogy was very clear. Local schema was in Chinese, component schema was in English, export schema was filtered on the component schema in English, federated schema was a combination combination of export schema from both Chinese and Japanese, and the external schema is one which are for the respective departments. And that is what happens. Local schemas of two local schemas, each may be from different relational database management system. Then they get translated into your component schema, which is in the same relational database management system. Then that decides what tables to share, what tables not to share, what type of operations are allowed in the table. That becomes part of the export schema. Then these export schemas are integrated to arrive at federated or a unified schema called the federated schema. And the unified schema gets distributed based on the requirement of different applications as external schema. Now this becomes a 5-level architecture. So this was gradually happened over a period of time. Then because this 5-level architecture had 2 types of heterogeneity that was supposed to be addressed, especially the heterogeneity due to syntactic and heterogeneity due to semantic. The syntactic was addressed, but semantic was much more difficult to address. Semantic heterogeneity can be like, the homonyms, the type of situation when you say 2 words, two people may have used same word, but may have different meaning. That is the case of homonyms. Maybe 2 people may have used different words, but they have the same meaning. This is the case of synonyms. So the idea was to address these heterogeneities in order to find out what were the similar things, what were the dissimilar things. Then there came a concept which was adopted from the area of psychology, which is called the ontology. So the ontology-based data integration came into picture, where we talked about ontology. Now this term was introduced by Tom Gruber, who described it as a formal explicit specification for shared conceptualization. So in a layman perspective, this terminology is called common vocabulary. So this was a common vocabulary. So all there was a common vocabulary that was built, and these common vocabulary had mapping to the respective uh, data in the respective data sources. So that was the case of ontologies came into picture. So the semantic heterogeneity was addressed using the concept of ontologies. Hold please. So there came the concept of ontologies. Now, ontologies was able to address what is called the semantic heterogeneity, which was much bigger challenge. Then, since another aspect, along with the heterogeneity aspect that these databases carried, there was another aspect that came into picture is that the data which was residing in a centralized database system was morely a transactional data. That is, it was for the operational processing because it only carried the current data and did not have the past data. That is the historical data. Now, what needs to be done is that, for analysis purposes, where current data may not be of much use, you need to use the historical data for analytical purposes. Why, for example, somebody wants to understand that how a person spends money in a particular month after getting a salary. Some a person may spend on second day, fourth day, eighth day, ninth day. So in a transactional database system, you will get the last spending of a person and the data updated based on the last spending. But you need to keep track of how he spends over a period of time, because that will give you an idea to any organization that how he spends that money, and accordingly how he spends the money, and then over a period of time they can define strategies that how to approach him, target him as a customer for a particular type of product. So this concept came, and then there came a concept of data warehousing, which happened to be creating a central repository of data which carried out historical information, historical subject-oriented information for analytical processing. The terminology was considered as a data warehouse as a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of managerial decision making. The idea was to address analytical processing, unlike the one which was carried out in the databases, which was mainly for transactional processing. Now, analytical processing are something different because you need to keep track of the historical data to analyze the data. So there was analytical processing at place. Now, the ultimate goal had been, in either of the cases, gradually the database research went into the case of why to derive wisdom from data. In my next lecture also, I will tell you about this pyramid, how computational intelligence and soft computing enables arriving at wisdom from data. But the ultimate goal was to derive wisdom from data. Now, what does it mean by deriving wisdom from data? You have data which is usually collected, it's a raw fact which is available. Now, this raw fact is more or less a fact in abundance, but it is not organized or meaningful. So if in order to use such data, you need to organize and make it more meaningful. So you do some sort of a processing on such data, and that processing is called information. Processing of such data is called information. So you do some sort of processing on data. Somebody has raised hand. Who is this? Is somebody named Sakti Vel? Shakti Vel? Excuse me, can you hear me, any of you?
Yes, sir.
Yes, sir.
Yes, sir.
Why somebody has raised hands? So you need to give some meaningfulness, and you need to organize such data and give some meaningfulness to the data. So you need to process data so that you, or in order to organize it and give some meaning. And that processed data is called information. So information is a processed data. After processing the raw data, you give meaning to it. That is in the form of information. Now the information is more meaningful than the raw data you have collected. Now, by using the information, you need to infer something useful out of it. Infer something very important, useful, valuable, interesting out of it. And that is what is called knowledge. Knowledge happens to be something which is an inference from information, something valuable, something interesting, and something useful. Now, just merely knowing, having knowledge is not good enough. You need to also ensure that this knowledge is put into action. So the actionable knowledge that is put into real work, real application is called wisdom. So wisdom happens to be the actionable knowledge. So the ultimate goal in any data science or in any data science, in any data community is to actually find wisdom from data. And data is raw, and you need to compute wisdom from. So the data science purpose is to actually find wisdom from such data. So data science is an interdisciplinary field that uses scientific method, processes, algorithms, and systems to extract knowledge and insights from data in various forms, both structured and unstructured, similar to data mining. Data science is a concept to unify statistics, data analysis, machine learning, and their related methods in order to understand and analyze actual phenomena with data. It employs techniques. Now, it is a combination of various areas. It does not restrict to computer science. It's a techniques and theories drawn from many fields. Within the context of mathematics, it talks about a lot of mathematics, a lot of statistics, information science, and something called computer science. And you know the theory about winner, Jim Gray imagined data science as the fourth computer paradigm of science. You had started with the empirical, then the theoretical, then computational, and now it has become more data-driven. And still everything about science is changing because of the impact of information technology and the data delivery. Now, what this data science is all about? Data science has several stages. It has data acquisition, data preparation, data mining and modeling, visualization and action, and model recomputation. So what is data acquisition? Data acquisition talks about extracting data from multiple data sources, integrating and transforming them. Now, you extract from multiple data sources because the data may lie in multiple data sources. Then you need to integrate and transform the data in a homogeneous format. Why in a homogeneous format? Because data may be having in a heterogeneous format. You need to integrate them into a homogeneous format so that you can have one specific query language to access this data. And then you load the transformed data into a data warehouse, and then you do some sort of an analysis on data. Then once the data acquisition is done and the data has been stored into some sort of a central repository like a data warehouse, then you talk about preparing the data. Data preparation may talk about handling missing and null values, and you know that in most of the forms you fill, you find that you actually fill values which have star associated with it, and wherever star is not associated, you do not fill values. And therefore, you need to see how you address those missing values and null values. And usually these missing values are represented as null because they are not values which are neither they are blank, neither they are zero. They are something which are not known. Then you do transformation because we know that every data is at a different range. Some may be in pounds, say for example, some may be in dollars. So honey, you need to do some sort of a transformation so that they are in one currency. Similarly, in weight in kilogram, weight in pound, again, you need to do some sort of a transformation so they are in one region. So data transformation may have normalization. You may ideally normalize so that they come to the same scale. You do some sort of standardization. We now talk about the Z standardized score. You try to make it categorical as numerical or similarly numerical as categorical. Then you talk about handling outliers. Because outliers are very important. Because the point is any fraudulent activity is actually an outlier. Because everybody makes transactions which are very normal. And suddenly when they make a transaction which is awkward, it's an indicative of fraudulent transaction. For example, suppose you are making any payment to India through your credit card, it will be considered as normal. But if you suddenly use the credit card abroad and without informing the bank, then it may be possible that the bank finds that how come a credit card has been used abroad? It is an indicative of a fraud. But that's why the bank starts sending you messages to find out whether it was you who was actually using the credit card. Then there is something very important, that is the data integrity. Data integrity is very important. It is the accuracy and reliability of data. Because today in the web, you have a lot of data which is available on the web. And not all is trustworthy. So you need to identify which data is reliable, on which you can trust and therefore can use it for analysis purposes. Now there is something called data reduction. Now it's a very interesting problem of a dimensionality reduction problem. Whenever you use some data, there are many features sometimes, and data becomes huge. It's so difficult to compute based on the amount of information that is available. That totally because there are too many features that you need to take into account. So then there is something called dimensionality reduction, which talks about how you can reduce such features. There are several techniques like feature selection and extraction techniques that reduces the number of features so that the computation becomes more feasible. So you sometimes talk about data reduction as part of the data preparation phase. Once you have prepared the data for analysis, next stage comes is something like column mining. Now, when you talk about warehousing, we were talked about analysis of already existing data, which we were trying to aggregate in some form or the other, and we were using it for analysis. But mining is something different. You have several perception in real life. You may perceive several things in real life, and you may find it in data. But sometimes data is actually more real. It's more reality than what you perceive. Your perception is also part of reality, but the data is more reflects reality much better. And why I'm saying is that it may be possible that you may find in data something more interesting, which you may not have perceived in beforehand. This is a famous example of beer and diaper. So when there was a study in a Walmart where they wanted to find out what items are bought more frequently, amongst so many items, they found maybe bread and butter, bread and jam, pencil and eraser, pant and shirts, or anything. They found that beer and diaper were also frequently being part of transactions. So that was surprising because nobody could have perceived beforehand that beer and diaper would have any relation with each other. And they would never have perceived that they would be part of many such transactions. So that is what mining is, because it's a valid, because it's there in the data. It is novel because it was not obvious to the system because nobody could have perceived beforehand that beer and diaper would have any relation with each other. It is useful and it is understandable because you need to understand them, and it is useful because you never had a strategy beforehand because you never perceived, so you never had a strategy. But now data shows such a thing. Now you will be making a strategy for it. And sometimes before making a strategy, you need to understand, you need to visualize, you need to understand the reasons of such scenario. It is possible that people started making various reasons why such a thing would have happened. Some people assumed that young couples in US go on a long drive on a weekend, may have beer and have diapers for the child. Some people assume that young couples watch American football matches in the weekend in order to not get disturbed by the child. They have diapers for the child. In either case, you need to understand what is the reason behind it. And then, since I said knowledge is just a perception, you need to act on it. And that is where, how do you utilize this? So this is useful, but you need to use it for defining some strategy. So strategy may be either keep, the beer and diaper in the adjacent shelf, because somebody who comes to buy beer is likely to buy diaper because he sees the diaper goes by. It is also strategy can be you give some discount on the beer while buying diaper, and you give some discount on diaper while buying beer. Or you keep them in a very extreme shelf so that anybody who comes for beer, he will, while looking for diaper, he may buy some more things. So it is possible that you may come across such scenario. Then data mining itself got classified into three. Data mining talked about various techniques. For example, it talks about classification technique. Then it talked about something called clustering technique and something called um, uh, association rule mining technique. So when you talk about classification technique, it talked about techniques where you were talking about having label data. When I say label data, for example, somebody who is a credit card holder in a bank, there may be many customers of a bank who may be credit card holders. They may have been already labeled by the bank based on their past history that whether they were good customers or bad customers. So they were labeled as classed as good and bad. Now, this good and bad, because that label has been given by the bank to those customers, a model is developed. A model is learned in such a fashion that it is able to identify, given other attribute values, it correctly classifies them in good and bad as classified by the bank. Now, why this model is constructed is because for any future customer who comes to the bank, you give all these initial values of the customer to this model, and based on that values, based on the past experience the model has, based on which it has been trained and learned, it will predict what the future customer is likely to be. If the future customer happens to be a good customer, the bank will issue them a credit card. In case the future customer is not a good customer, the bank will deny him the credit card. Now, this is based on the classification model because it assumes that the classes are already predefined, and in this case of credit card, also the classes are already predefined because the class labels are already given by the bank as good customer and a bad customer. Now, what is the scenario when the classes are not clearly defined? That is the case of clustering. In clustering, you don't have predefined classes. I will give you a very interesting example about clustering is that when students come to a class to join a program, they come from various different places across the country. So they hardly know each other. So initially what happens is each and every student tries to interact with a other student. So gradually what happens after maybe a month or two, you will find a group of students getting created out in the class. Though groups may have students who may have interacted with students in other group, but gradually the groups get created. What may be the reason of such groups is it may be possible that the groups, the students who are similar in some characteristics may have formed one group. Some students would have been good in sports, they would have loved sport, they would have formed one group. Some students may have been good in, they are good at studies, they want to study, they may have formed one group. Some students who would like to play maybe a video game or something, they may have formed one group. So based on some sort of a similarity, the groups gets created. So unlike classification, which is a priori classification, here it is a posteriori classification. When I say posteriori classification, I mean today the classes are defined from data. The classes are defined from data, and the basis of such classes is either the distance measure or the similarity measure. Either the points are very close to each other or very similar to each other, they form one class. Okay. So the clustering was something classified into unsupervised learning. Unsupervised, as unlike the case of classification, which happened to be supervised learning by the labeled classes which are already provided. Then we move to something called association rules. I have already taken an example of association rule in the case of the beer and diaper example. In the beer and diaper class example, I have already talked about that the idea was to find out what items are bought together more frequently. The association line is a procedure which is meant to find frequent patterns, correlation, association of causes, structures from data sets found in various kinds of databases such as relational, transaction, and other forms of data repositories. So like you can see here, there are nearly 7 transactions. Each transaction has different items being bought. So you need to find out which items are bought together more frequently. And that is where the association rule mining came into picture. Again, this was unsupervised learning, but here the idea was to find what items frequently occur together. And there were several algorithms for association rule mining, especially one which talks about the a priori algorithm, which talked about which has already it was based on 2 a priori principles. The 2 a priori principles happen to be that of the subset of a frequent item set will always be frequent, and superset of an infrequent item set will always be infrequent. So that was the a priori principle into the situation. Again, there was something called web mining, which was originated from mining. Now the point is, people could have called it data mining as well, but because when you talk about web mining, we are actually dealing with more or less on semi-structured or unstructured data that is mostly available on the web. Especially, you have the content of the web page, the links between the web pages, and the way the user uses the web pages. But they prefer to call it web mining because when they say data mining, they are actually stating that data mining is related to something structured data. When you mine structured data, they wanted to understand what would be define something which mines semi-structured or unstructured data. So they could have called data mining, but they preferred to call web mining as most of the semi-structured unstructured data resides on the web. Now, then you talk about mining the web is also classified into three levels. It can be mining a web page, that is web content mining. It can be mining the links between the web pages, that is the web structure mining. It can be mining the way the web pages are used by the user, that is called the usage mining. So the web mining itself got classified into content mining, usage mining, and structure mining. And several techniques like classification, clustering, and association mining were used to address the web mining issues. Now, this is what we talked about in the context of usage. Now, once you do some sort of a mining, then you do visualization, and then you do recomputation as part of the data science step. You do some visualization in the sense what you do, once you have inferred some knowledge out of it, you need to understand what is that knowledge, and then you need to put it into action. As in the case I said, that when people found that beer and diaper were part of many such transactions, they put that knowledge into practice by either making strategies how they can increase one by how they can increase the sales of one using the other, either by giving discounts, either by their location in a supermarket. Now, in either case, when we talk about data science, the challenge now is the amount of data that is being there, the complexity of data that is being there. The complexity is not only associated with the volume of data, it also associated with the heterogeneity of data. Because today the data is not merely structured tables or rows only. It talks about unstructured data in the form of text, the video, the audio, the picture, images in different formats. So data is no more, it has become more semi-structured and unstructured over a period of time. Okay, so now you have this now because and then the third aspect is the now today, because of the advent of technology, we have these sensor devices, the IoT devices that are generating data at a very high speed. Now all data needs not be stored. Some data can be analyzed when they are in the form of streams. Now the third issue which came into picture was the rapidity in which the data was getting generated. Now that was very important, because now the processing has no more been only analytical processing. Now it has gone beyond, it has become more real-time processing. When I say something is real-time processing, I mean to say it is not all about getting a correct answer, but correct answer within the stipulated time. That is more important. If it goes beyond the stipulated time, then the correct answer has no values. So now today the things have become more real-time. Even the streaming data needs to be analyzed in real time so that decisions can be taken in real time, so that nothing is lost. Okay, so that is very important. So that's why the data complexity was there, and that's why we come across the term what is called big data. Now big data has its own now because what has happened is over a period of time technology has advanced. People have now ways to capture this data, and now they find the motivation behind capturing some data and analyzing it, and that has analyzing it has become a much bigger challenge today. For example, suppose I talk about an increasing sensor enabled and instrumented business environment. I talk about a case where I talk about a situation where you can just see 1 billion lines of code. Each engine generates 10 terabytes every 30 seconds, 30 minutes. Then, for example, earlier people were used to think about posting a photo, and you just merely thought about seeing a photo, that is enough. But today even a photo carries a lot of metadata information which can be very useful for people. So for example, in August of 2000, Adam Savage of Mythbusters took a photo of his vehicle using the smartphone. He then pasted the photo to his Twitter account, including the phase after work. Since the photo was taken by a smartphone, the image contained metadata revealing the exact geographical location the photo was taken. By simply taking and posting a photo, Savage revealed the exact location of his home, the vehicle he drives, and the time he leaves for work. Just see the amount of data that is there in a photo itself. It is the metadata which people were looking forward to analyze. Now, for example, some sort of time we have this Facebook where 90%, more than 90% of the chats are more informal, but these informal, some of the chats may be very useful to the organization. For example, somebody is trying to say happy birthday, Poya, I can't believe you and your son was born on the same day. April 1st was no Fool's Day in 1975, nor was it in Sebastian in 2010. Just imagine, you have actually revealed the date of birth of two people here. Then similarly, there is some, most of the things are noise. Then somebody had actually mentioned I had an iPhone, but it's dead. I have no idea where it is, and I want a BlackBerry now. Now somebody is looking forward to buying a phone. Now this also, the companies are very interested because they will find a customer, and that is how they are going to target a customer in terms of selling their phones. And similarly, most of them are noise. So you can understand that name, birthday, and family is revealed here. Not relevant is more of noise, and there's something has a monetization intent where somebody can identify that somebody is looking forward to buying a phone, and this is how we can approach that person to sell the phone. So sometimes the idea is now people are now more interested into the chats even that goes on our Facebook, the Facebook account. Now people want to understand, can we find something useful there which can be capitalized and exploited to actually increase the business value. So what is big data actually? In a layman, it is big data refers to a collection of data sets so large and complex and impossible to process them with the usual database and tools. Due to its size and exclusion, big data is hard to capture, store, search, and share and analyze. Now, what big data is, if suppose I give you a very layman example about big data, I take a small hammer and I have a small table in front of me. So I can use the small hammer to break the table. But suppose somebody asks me to use the same small hammer to break the wall, it will not be possible because wall has its own complexity because of its size, the thickness of the wall. Now the thing is, that is what the data difference between data and big data is. The tools and technologies that are applicable for data, and they are no more applicable for big data because of its complexity. That complexity may be due to certain factors. But where this data is getting generated is one thing that has added to the complexity of data. They have been generated because today the scenario is totally different. Earlier, we were actually thinking about a scenario where the industries were producing data and we were consuming it, but today the scenario has totally changed. Now, today's scenario is that everybody is producing it and everybody is consuming it. We have data being generated from mobile devices, the RFID, the sensor network, the social network, the internet searches, automated record keeping, video archives, and e-commerce. Coupled with even the analysis of data is huge, quite huge. And that is why, it adds complexity to data. What type of complexity adds? Now, in terms of size, we have the complexity as is in terms of volume, the amount of data that is getting accumulated and stored, velocity, the data, the amount, the speed in which the data is getting generated, variety, the type of heterogeneous data that is available, and most important happens to be the veracity. Veracity is the trustworthiness in the data. How trustworthy data is. Because of the huge amount of data that is available on the web, you can't trust on each and every data that is available on the web because this data is, all data is not trustworthy. That's why there have been research in trying to compute the trust associated with each and every data, and then consider only those data which has trust value beyond a particular level for analysis. So trust is also, and that veracity happens to be one of the most important aspect of big data. Now, how things have transformed. We started with databases, we talked about online transaction processing, then we went to warehousing, we talked about analytical processing, and now it is called RTAP, that is real-time analytical processing. This is the case in the case of big data architecture and technology. As I said, the model has totally changed. Earlier, few companies are generating, all others were consuming it. Now all of us are generating and all of us are consuming it. The bottlenecks is there in the technology, the architecture, algorithms, because whatever was applicable for data is no more applicable for big data. So you need to look for new architectures, algorithms, techniques. Similarly, you need to look for skills. That's why in the IT scenario, they say that most 80% jobs in the future is likely to be data scientist jobs. You need to have experts in using new technology and dealing with big data. So big data conundrum is the percentage of available data an enterprise can analyze is this scheme proportional to the available to it. Is big data the same as data science? Are big data and data science the same thing? Maybe not. Data science can be done on small data, and everything that is done on big data is not necessarily data science. But yes, there is a considerable overlap between the two. Okay, so data science looks to create models that capture the underlying patterns of complex systems and codify these models into working applications, whereas big data looks to collect and manage large amounts of varied data to serve large-scale web application and vast sensor networks. Data science and big data can be summarized in one statement: collecting does not mean discovery. So again, we come back to this pyramid. We come back to this pyramid by saying that this is where the next talk will start from. Again, we talk about ultimate goal is to start with data, which is raw, give it meaning, it becomes information, infer something useful out of it, that is knowledge, and put the knowledge into action. That is the ultimate goal, that is called wisdom. So the ultimate goal is to find wisdom from data. Now the data has grown in size, it has become big. Now it becomes a much bigger challenge to get information, knowledge, and wisdom out of it. And that is where the data science aims to do. Thank you very much. Anybody has any questions? Are people there?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Does anybody have any questions? I will have the next talk. I will talk about more of
Sir,
computational
I am
intelligence.
having one question. Can I ask you?
You
Yes.
can ask, but others please mute. Others please mute. One, if whosoever is asking, can they raise hands and I will just get back to them. Okay. Yes. Yes, Jyoti.
Okay, sir. Data mining, whenever we are in data mining, whatever we are doing that things, which depends on which parameters, sir. And second one is there any systematic procedure is there for data mining, sir?
That's why you call something called knowledge discovery in databases. That is as a systematic process where data mining is part of such process. You talk about data gathering, data pre-processing, data integration, and then you talk about data mining, visualization, and interpretation. So there's a systematic way of doing data. And then depends upon the type of problem you are getting addressed. As I said, if you have already got labeled data and you look forward to find labels for the future data, you talk about classification, that is supervised learning. If you do not have labeled data and you want to create classes or groups out of it, you talk about unsupervised learning. If you want to find some sort of things in terms of the frequency of occurrence of something, you use association rule mining. And that is how you talk about, given the data and the objective you have, you use the respective techniques to address or address the objectives. That is what it is. Okay, Jyoti. Who
Dear
is there?
participants, any more questions or query? Any discuss with the professor?
Minati.
Sir, actually, from slide number 32 onwards, it is not moving, sir. I could not see.
Yeah,
Slide number 30.
yeah, but it may not be moving in your place, but already it is there in my.
Okay, okay. Oh, that's why I am asking.
You want to see something there?
Yes.
Yes.
Yes, sir. Thank you. I got.
Huh.
Now it's moving. Okay. Okay. So thank you. Thank you.
Anything you want
In
to
data
ask?
mining, can
Yes.
hello, data
Yes.
mining it
Yes.
can be affected by virus, sir. How it can be protected?
Can be. What?
Protected.
What to be? What to be
The
protected?
data we have, whatever data we are storing in a mining, sir.
No, you don't store data in mining. You mine on the stored data.
Okay, sir. That one. But we have to protect it from
That
and
that is a
all the
different issue
problems
altogether.
are coming in.
That depends upon data security and privacy issues. That is intellectual property rights, and that is another issue. Because you will only talk about access only the
Okay,
data
sir.
which you are permitted to access. You cannot access any data.
Okay, sir.
That's why there are a lot of
Okay,
published
sir.
data
It
which
will
are
be
available on the
becoming
web.
lot of lengthy.
No, it is already
Yeah,
available. A
it
lot
is
of published
becoming
data.
lengthy one. So,
A lot of published data is already available on the web, so you can access that.
okay, okay. Thank you.
Anybody else?
Hey,
Any
participants, any
anybody else?
query discuss with professor in doubt or depends upon any.
How many of you know what is big data? How many is aware? How many of you are aware of big data? Can anybody tell me what is the challenge with big data? Anybody?
Participants,
Hello,
Yes. Who is this?
is it not? I'm Lakshmi.
Okay, tell me.
So big data is it is in voluminous and variety,
Hmm.
and extracting knowledge is the biggest challenge now.
Hmm. Knowledge has become
And hello, hello.
extracting knowledge. No, extracting, analyzing it has become bigger challenge. The reason being that whatever is applicable
Extracting
for
such large volume data is tedious one now. It is
but
the
as
biggest
I
challenge.
but don't think only volume is important. There is a lot of
Okay.
issues. Even the heterogeneity of data, whether the data is trustworthy to analyze, that is also equally important because you cannot analyze all data that is available. You need to associate some trust with every data, and then
Yeah.
pick the data which has trust level beyond a threshold, and then the velocity, the speed in which getting the data is generated. So you need to keep your model. You need to keep recomputing your model because the trends keeps changing and your model should address and cater to those changing trends. That is also
Yeah.
equally important. So all these are very big challenge when it comes to big data, and that's why the data science thinks about addressing such challenges in big data also.
Okay.
So again, I said there's a substantial overlap between big data and data science, but everything with big data is not data science, and data science can also be done on small data or data. I won't call small
Sir,
data.
and one issue is that we have to whatever data we required that once generated data we have to use repeatedly for at any time whatever we wanted, sir. It
No,
so
no,
we required it, no,
no. You require
for
that's why
analysis and interpretation.
that is why the generated data nowadays they are published data which is available on the web. You can use that published
But
data.
that is whatever data published and it is available in the web. But sometimes we required for result oriented data, no, whatever.
No, but that is why the data preparation comes into picture. You never
Yeah,
get
yeah,
data
sir.
which you can directly use. So you need to prepare
Yeah,
it
yeah.
so that you can use it. That's why data
Yeah,
preparation
yeah, we
is
have
one
to
of the
work
stages.
it.
So that's
Yeah,
why
yeah,
data
sir.
preparation is one of the stages of data science, isn't it?
Yeah, yeah, that is true, sir. Thank you.
Okay. Anything else? Anybody who wants to ask questions? Somebody, Santha Namari E, has raised her hand. Maybe by definition, I don't know whether some, but somebody has raised hands. Any more questions from anybody? Just lower your hand. Okay. Anybody has any questions?
participants, I request interaction with the professor. The professor is waiting for whatever may be.
You know what is you? Do you understand what is real-time analytical processing? Anybody can tell on that? That is very important when today's scenario is concerned. We are not talking about analytical processing, but we are talking about real-time analytical processing. Can anybody say anything about real-time analytical processing?
Students, research scholars, any asking, discuss with the professor or query for your query?
Anybody can say anything on real-time analytical processing? You know what is real-time systems? Anybody knows real-time systems? How it is different from any other system? Can you tell me what is a real-time system and how is it different from any other system? I'm expecting some answer. You must be from computer science, sir. What is a real-time system?
A real-time system is a time-bound system. So it should be used. So based on the data, we have to act accordingly with the fast manner.
So why in today's scenario the analytical processing needs to be in real time? What does it mean? You understand that? Because it's not. I have been saying that it is not all about getting a correct answer is important, or an answer is important. It is all about getting an answer within a time is important, because beyond a particular time it loses its importance. So anybody who can get answers efficiently is likely to be more competitive and can be more competitive in the even in the business scenario or in the real world applications also. It's like saying that it's the vaccine you need to find for a pandemic. It's not all about finding a vaccine, but find vaccine within in less time as possible, so that many lives can be saved. So that is where the real time is all about. Any more questions? Oh, Gandhiji, then what I will do is I will just take a 20 minutes break, 11:45.
Okay, Professor. Okay,
I
Professor.
will meet again, and I will talk about the computational intelligence, some AI, artificial intelligence, and soft computing, something like that. Then maybe I may talk about a little bit more machine learning and all. Okay.
Okay, Professor. Okay,
I will come back at maybe 11:45, 11 around. Okay.
Okay, Professor. Okay, Professor. For your willing, Professor, at your convenient of time, Professor.
Okay, thank you.
Okay. 11:45, join, Professor. We were waiting, Professor. Okay. Okay.
Till that, everybody can have a small cup of tea, and then we'll get there.
Okay, Professor. Thank you.
Or do you want me to continue now? But I think let us have some break. I think other people who are hearing you should also have some break. Okay.
No, Professor. Recording is continue 1 o'clock still from 10 to 1 o'clock.
It is already continuing.
Yeah, yes, Professor. Yes, Professor.
Okay. Let me see. Are the participants going to be there, or should we start now?
Participation are waiting for a few minutes, Professor. No problem, sir. 11:45. Can you join, Professor? No problem.
I will join around. Okay. Let me join around 11. Try to join around 11:40. Okay. Just
okay,
take
Professor.
a small break.
Okay, Professor. Thank you, Professor. Dear participants, so waiting for again, Professor is given the lectures to at 11:45, 11:40. Okay. Thank you. Madan, சித்ராமா
அண்ணா சொல்லுங்கண்ணா.
இருக்கீங்களா?
சொல்லுங்க சார்.
ஓகேங்க. சார் 11:45 வரேன்னாருங்க. ஓகே வாங்க.
சரிங்க.
ஓகே ஓகே
அப்படியே ரெக்கார்டிங் கண்டினியூ ஆயிட்டு இருக்குதுங்க. ஓகேங்களாங்க? எதுவும்
ஓகே
பண்ணாதீங்க.
ஓகே
அப்படியே சிஸ்டத்துல இருக்குங்க.
ஓகே
ஓகேங்களா? ஓகே ஓகே. பை பை.
ஓகே
Hello. Hello. Hello.
Yes, sir.
So I think we should more or less start.
Professor,
Gandhiya ji, I would actually be speaking on nature-inspired computational intelligence. So I will come back line because machine learning I am more or less covered. So I'll be talking about. Are the slides visible?
Yes, sir.
Yes, sir.
Yes, sir.
So I'll be talking about nature-inspired computational intelligence. I think because it's a very important area and something which is derived from the area of artificial intelligence. Are we ready? Are the people there?
Yes, sir.
Gandhiya ji?
Slide not visible, sir.
Hey, Dr. Gandhiya is there? I cannot see him, Dr. Gandhiya. Dr. Gandhiya Vendhan? Is anybody there from the department?
Yes, sir.
Okay. So where is Dr. Gandhiya Vendhan? Excuse me.
Sir, he's online, sir.
No, I
Gandhi
can't see.
Vendhan, sir.
I can't see him.
Sir, I told him, sir. Sir, he's online, sir.
Uh,
Now, sir is online, sir.
should I start Gandhiya Vendhan ji? I don't know whether. Hello. Yes. Should I
can I
start
start,
now?
Professor? Yes, Professor. Yes, Professor.
Okay, then let me start. Okay. So I'll
Okay.
be talking on nature-inspired computational intelligence. Okay. So another very relevant area because of the type of problems we have, the data has, and the type of computation that is required. So now computer science community is taking inspiration from the creatures in nature, how they have optimized solutions in their real life. So before getting into this aspect of nature-inspired computational intelligence, one needs to understand what is intelligence. So intelligence has been defined in many different ways, such as in terms of one's capacity for logic, abstract thought, understanding, self-awareness, communication, learning, emotional knowledge, memory, planning, and all these things. Intelligence can also be defined in ways like a very general mental capability that, among other things, involves the ability to reason, plan, solve problems. So it's the ability to plan and solve problems. Nothing to do with literacy, nothing to do with education. It is how you are able to solve real life problems, how you are able to solve them in real time also. So that is where the intelligence comes. And somewhere on the line, there's something they wanted to have this intelligence simulated into machines. That is, make machines behave like humans, the intelligence that the human has. The one thing interesting about humans is that intelligence, the humans have two important capabilities. One is the consciousness in the sense that they know what they are doing, to whom they are talking, to whom they are interacting, what they are doing. That is one consciousness. Second is the ability of humans to perform multiple tasks. They can do multiple tasks as per their requirements. Okay. These three things are very big challenge. They wanted to have machines that behave like human intelligence. They wanted machines to be more conscious. They want machines to perform multiple tasks. And in 90s, they thought about having this AI, and AI is going to have machines that are going to behave like humans. And that is what they believed in. They thought that they are going to have such machines as the earliest. But actually, that did not happen. So let us talk about what is this artificial intelligence all about. It refers to the ability of machines to perform cognitive tasks, what humans do, like thinking, like perceiving, like learning, like problem solving, and decision making. So we are looking forward to programs that behave externally like humans, programs that operate internally as humans do, and computational systems that behave intelligently, having some rational behavior like a human does. Initially in the 90s, they believed that AI is going to, artificial intelligence committee thought that we are going to have machines that are going to behave like humans. And they thought that it is so easy to have such machines. So somewhere along the line, they overestimated AI in terms of its capability to build such machines. But gradually they understood that they, by overestimating AI, what the mistake they did was they underestimated humans. They did not understand the complexity of a human brain. So then they had to classify AI into two places in terms of weak AI and strong AI. Weak AI, we talk about simulated thinking. That is what in today's machines are. Even the chatbots are simulated to interact, and that is where thinking, they don't know why they are doing it, to whom they are doing it, but they're interacting. It's a simulation-based systems. But what humans do is the thinking which has consciousness, the actual thinking, which has been classified as strong AI. So today also the machines are very far away from the strong AI. Today also machines support what we talk about weak AI. Then again, AI was classified into narrow AI and general AI. As I said, ability of humans to perform multiple tasks. Today we have machines that can only perform single tasks. So they come under the class of narrow AI. But what we aspire, if a machine has to become like humans, behave like humans, then they need to support something called generic AI when we talk about having machines that have ability to perform multiple tasks, as though humans do. And that is where the terminology superintelligence came from. It is the combination of both generic AI and strong AI. That is, ability of a machine not only to have consciousness in terms of its thinking, but also have ability to perform multiple tasks. So that is what the AI community is looking forward to have machines that are super intelligent. So you have hardware, software-based systems that have the following properties in terms of autonomy, social ability, reactivity, and we are looking for a robot that can do the same thing. We know Alan Turing because we don't have a Nobel Prize in computer science. The highest award in computer science happens to be the ACM Alan Turing Award. That is after Alan Turing. Alan Turing is well known for his Turing machine. He was also instrumental in winning the World War II by the Allied forces. Was also had that Enigma code. Now there is one famous test of Turing test in AI, which talks about that if it's like saying that if you put a curtain between a human and a machine, and the human does not know the other side is a machine, and the human keeps interacting, and keep getting responses from the other side, like any human would do, and when suddenly this curtain is removed, you find it's a machine, not a human. That day they feel that the Turing test will pass. So AI community is thinking about how to ensure that this Turing test passes. So that is what the AI talk about. But interestingly, you must have heard about Stephen Hawking. Am I not presently? Are you able to see the slides?
Yes, sir.
Yes, sir.
Sir.
Okay. 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 So you must have heard about Stephen Hawking. The Stephen Hawking actually said that the day AI succeeds, you're able to have machines that behave like humans, that will be the end of humanity. He believes that if AI can be constructive, at the same time it can be very destructive. The day the machines start behaving like humans, they are much more computationally more powerful than humans. You don't know what is going to be the state of the humans. So sometimes, on a lighter note, people say that today we go to zoo, we find animals. Maybe when we have AI and robots who are behaving like humans, you never know. We are going to have a human zoo instead of an animal zoo. You never know what may happen. So some of the AI applications happen to be finding the shortest route by visiting relevant cities, autonomous planning and scheduling of tasks, even having machines which are expert systems which are based on them, beating Garrett Kasparov in a chess match, steering a driverless car, understanding languages, robotic assistance in surgery, monitoring trade in the stock market to see if insider trading is going on. Now, these are the AI applications that are there. But my focus will be something that intelligence that have been, people have found in how the nature has been intelligent enough. Now, just see the nature itself. You can see the nature. Interestingly, in nature, there is no education, there is nothing. But how the nature learns and optimizes solutions in real life. So sometimes whenever I try to deliver talk, I say only unnecessarily humans believe they are intelligent. There are creatures in life which are much more intelligent. Maybe the individual creatures may not have that much intelligence as a human, but they have such a wonderful socially organized structure that individually they do not do much, but together they do a lot of things. It's like a Helen Keller statement that comes into picture. Alone we can do so little, together we can do so much. Individually they are not intelligent, maybe together they show intelligence. Now you can see the evolution of man, and that has led to something algorithms like the genetic algorithms, that is the evolutionary algorithms. Then you have these behaviors through to ants. Now, this evolutionary algorithms, the genetic algorithms have come from the inspiration of the Darwin's theory of survival of the fittest. It believes that the fittest are likely to survive and less fittest are likely to die. So fittest, if they survive and recombine, they are going to produce fitter offsprings. And less fitter are less likely to survive in the environment. Okay, and that is where you have that inspiration from the survival of the fittest that has led to algorithms like genetic algorithms to solve very important computational problems. I will get back to the problems that they can solve. Okay, then we have something called mean. You people must be aware of gene, but hardly people must be aware of mean. Gene is something which comes through generation and generation. Meme is something which comes within the generation. You may acquire characteristic, like suppose you want to become a teacher, you are a student, you attend classes from a teacher and then tries to learn how to teach. That is something you may have that comes from an environment. Maybe your parents may not be teachers, but definitely you go to a class, you may become a teacher because you learn how to teach through the environment. That is what we call a meme. So there are something called genetic algorithms, there are something called memetic algorithms as well, which are there. Now, the type of nature-inspired techniques provide many efficient ways to solve problems. Algorithms which imitate process nature-inspired from nature to solve novel problems are called nature-inspired algorithms. Gaining much popularity in recent years, many real-world optimization problems have become increasingly larger, complex, and dynamic, both in terms of time and size. They come under the category of NP class problems. If anybody knows what these problems are, they are actually the problems are categorized as P class problems and NP class problems. P class problems are polynomial type problems, which can be solved in computationally solvable in polynomial time. And NP class problems are non-deterministic polynomial type problems, which cannot be solved in computationally in polynomial time, but can be but are verifiable in polynomial time. So we have, and then further we have these NP class problems into NP hard problems and the NP complete problems. So when it's you have solutions, you have algorithms that can solve P class of problems, but however you don't have algorithms that can solve NP class of problems. So one looks forward to algorithms that can solve NP class problem, which happens to be complex problems. Let us talk about what type of problems nature-inspired computing may solve. For example, when the search space is too large, when I say search space is too large, you have too many solutions in a search space. It is so difficult to find the number of solutions you have because they are huge in number. Forget about evaluating them, even if you cannot find them. For example, let us consider a traveling salesman problem. If you see a traveling salesman problem, if there are 100 cities, the number of it's a permutation problem. The number of solutions are going to be 100 factorial. Just imagine to compute 100 factorial is itself difficult. How would you know those 100 factorial solutions which are there? So unless you explore the search space, there is no way you can find the best solution, or no way you can say that a particular solution is the best solution. But it is so difficult to explore the search space in real time. You cannot do it in your lives, not in your children's life, generation after generation, because they take huge amount of time, because it's finding solution itself is difficult. Computing them is much more tedious. So when the search space is too large, there are no deterministic algorithms exist which can find the best solution to the problem. But then you have to see that if you cannot find the best, then you are looking for a good set of solutions to the problem. There nature-inspired computing can be of great help. So like it says, when the best solution is not necessarily required, that means either it is not possible to find a best solution, or in some cases you are looking for a certain objective to be attained. In that case, you may not be looking for a best solution. For example, somebody says, I want a 1 million profit. If he keeps finding solution till he gets a 1 million profit, even if he could have found 2 million profit, but his objective may be only to find a 1 million profit. It's some sort of a constrained optimization problem. Then you have something called approach of solving is not well understood. Sometimes the approach is not well understood. You cannot ideally easily formulate this as a mathematical problem. But you know this happens, but there is no way you can formulate it. In such problems also, nature-inspired algorithms can be of great help. Even sometimes the problems in real life are usually not single objective. You know, the problems in real life are never single objective. Even while buying a car itself has two objectives, at least two objectives. Like you want to maximize the comfort and minimize the cost. And it can have several other objectives, but in real life, no problem has single objective. So usually the problems are multi-objective, and there are ways of solving multi-objective problems. In classical optimization, we use goal programming to solve such problems. But again, we don't have it is not possible to find best possible solutions to such problems because of the subspace being very large. In that case, you resort to such nature-inspired algorithms to solve such computationally expensive multi-objective optimization problems. So as I said, you can just see the traveling salesman problem. It's like a traveling salesman problem is defined as a problem with, if there are n cities, a traveling salesman has to visit every city at least once, at most once, and come back to the original city. So that means he does not visit a city twice, but at the same time, he cannot miss out a city. So it's like saying that if these are the cities, then he has to actually move to these points, locations, and then he has to come back to the original place. And this is the idea. The objective of such problem is to minimize the distance traveled or minimize the cost. Cost can be computed in terms of the distance. So that is the idea about a traveling salesman problem. But this problem is a permutation problem because the ordering in which the cities are visited may lead to different cost. So it's a permutation problem. At the same time, it has some possible solutions. As I said, if there are n cities, there are going to be n factorial solutions. And then if the n value is very large, then computing the possible number of solutions, it becomes very difficult. Computing the number of solutions is difficult. Forget about evaluating those solutions. Okay, as I said, computing 100 factorial is almost infeasible. Okay, so it's like saying the type of number of solutions, the search space we were talking about earlier. If you have 10 cities, 181,000 solutions, 20 cities, 10 raised plus 16 solutions, 50 cities, 10 raised plus 60 cyclic permutations are there. And just imagine computing these values itself is very difficult. Forget about finding this number of solutions and evaluating this number of solutions. So there have been several algorithms, nature-inspired algorithms that have been used to solve such problems. These actually they are also called meta-heuristic algorithm. We know heuristic is to search, and heuristic is to find. And when you incorporate randomization into heuristic, it becomes a meta-heuristic method. So it is a method. Meta-heuristic is formally defined as an iterative method for exploring and exploiting the search space. Usually we have classification to evolutionary algorithms, the swarm techniques, the bio-inspired techniques, and other meta-heuristic techniques. Now what is meta-heuristic? If I want to make you understand this meta-heuristic, let me make you understand. If while you go for you go into a mall for buying some clothes, some things in the mall. For example, suppose you want to buy a mobile in a mall. Now let us understand what is heuristic and what is meta-heuristic. Okay. You want to buy a mobile in a mall, and there are 10 floors in a mall. Every floor has maybe 10 shops. So in all, there are 100 shops which are selling mobile in a mall. Now, heuristic may be that you know that you cannot visit more than 10 shops, and you have to decide after visiting 10 shops or maybe 20 shops, and then decide. So you keep a target that I won't visit more than 20 shops, and I will, after visiting them, I will buy the mobile from the shop which gives me the best price. So heuristic may be you can go to the first floor, you visit all 10 shops, go to the second floor, or visit all 10 shops, and done. So it's nearby shops you are looking forward to and just doing it. But what has happened in this while is that you are only able to explore first and second floor, but you could not go to the third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th floor. So it is possible that you would have got mobile at a cheaper price on this floor. So you are only happy that you got a mobile at a best price from amongst those 20 shops you have visited in the first and second floor. However, you cannot claim that this solution is good because you have not explored 8 different floors. But what meta-heuristic adds to this is it adds randomization to it. So what randomization means is that instead of sticking to only 1 or 2 floors, you may visit one floor, maybe go to 1 or 2 or maximum 3 shops, then randomly go to the second floor, 2 or 3 shops, again to the third floor, and so that you visit all 10 floors, either visiting 1, 2, or maximum 3 shops in each and every floor. So that is what you may do. In that case, what may happen is that you may have the flavor of the prices, the type of mobiles you be sold in each and every floor of the mall. So if somebody asks you which will get you a better solution, will it the one where you have visited 20 shops in first and second floor, or is it the 20 shops you have visited across all 10 floors? Obviously, the one which is 10 floors is much more appealing, and the solution is much more likely to be better because you have explored all 10 floors. So even if you have explored only 20 shops, but you had the flavor of all exploring all 10 floors, so that's why these algorithms are more likely to be this thing. But interestingly, what has happened is in either case, there's no way I can visit all 100 shops because I do have a time constraint. I need to buy a mobile within a time restriction, and I know within the time restriction I can only visit 20 shops to buy a mobile. But somehow I find that 20 shops, how should I choose? I can use a heuristic method to choose it, or I can use a meta-heuristic method to choose it. The idea is the balance between the exploration and exploitation. When I say exploration is how many shops I visit, exploitation is how much time I spend in a shop in bargaining to buy a mobile. If I do too much exploration, I may not be able to bargain in the shop. If I do too much exploitation, I may not be going to many shops. So I need to have a balance between the two. And the meta-heuristic algorithms tries to explore and exploit the search space to find the balance between the two. And that's why these algorithms are also nature-inspired algorithms are meta-heuristic algorithms, and they are actually classified into 4 types. One is the evolutionary algorithms. Evolutionary, as I said, is based on the evolution of man, where we talk about algorithms like genetic and memetic algorithms, where over a period of time things evolve. I know I've already told you about that genetic algorithm that has been inspired by the Darwin's theory of survival of the fittest. Then there are another class of algorithms which are called swarm algorithms. Swarm, as I said initially, maybe the individual creatures are not intelligent enough, but they are so socially organized, they can do much, a collective intelligence comes out of them. Though they are not similar, they are not intelligent individually, but together they achieve a much bigger task. Now, so there are techniques like swarm techniques, which are techniques which are inspired by this. So I will come back to these techniques. For example, you can see these techniques in terms of the bees intelligence, the ants intelligence, and I will come back to that also. Then there are bio-inspired intelligence, maybe like the artificial immune system, the antibodies that get created to fight the antigens, or you can have the bacterial foraging. And there are certain other techniques which are called other meta-heuristic techniques. Now, if you talk about annealing process, we know that you melt the metal to a liquid state, and while it gets gets cooled down, you can give it a new shape. Now, this is the annealing process. This has been simulated, and this has been simulated to solve problems like the traveling salesman. So the meta-heuristic, these are all come under the category of meta-heuristic algorithms, which solve the problem by exploring and exploiting the search space. Definitely, there is no way you can find the best solution to the problem because the possible number of solutions are very huge. So it is difficult to evaluate all possible solutions, and therefore you cannot find the best solution to the problem. However, you are looking for a good set of solutions to the problem, and meta-heuristic techniques help you in finding such solutions. Now, I talked about this. So we talked about ant and colony and bee colony. Now, interestingly, again, I said that the ultimate goal is to find wisdom from data. Now, let me give you an example of ants' behaviors and bees' behavior before talking about the inspiration through them. Ants usually you notice them on the ground, on the floors. And when do you notice them? When they are in bunch. How do you notice them? They're all walking in the straight line. And you know where they are going? Definitely, maybe. You know, ants initially are dispersed in all directions. The idea is they are all looking for food. And suddenly the ants which find food on the way back, they lay a chemical substance called the pheromone. And suddenly what happens is some paths have high density of pheromones, and that is indicative to other ants that this path leads to a food source. And gradually what will happen is all ants will start following that path to the food source. So one day one ant finds food, the other ant finds food, and this is the ability of ants. Individually they are not together, but together they exhibit some sort of an intelligence. This behavior is asynchronous in nature because ants actually communicate through the environment. How they communicate through the environment? They lay a chemical substance in the environment, which other ants notices and accordingly follows that path where this chemical substance density is very, very high. Now, this inspiration of ants, where the foraging of food has led to algorithms like what you call the ant colony optimization algorithm. So you can easily say ant has an interesting behavior. They can take load 10 times more than their weight. So what is the natural behavior of ants? Usually the ants will move in straight line. Suddenly, if you put an obstacle, you will gradually see that, if you can see, if you put a small obstacle, then what happens? There is one side is smaller and one side is longer. By the time one ant moves on the longer side, three ants may have already moved on the shorter side. Assuming that every time an ant moves on this side, they lay a chemical substance called the pheromone. And definitely you will understand that the shorter side will have higher density of this substance because, as I said, by the time an ants move on a longer side, three ants may have moved on the shorter side. So gradually what will happen that ants will start moving on either of these sides. They will deposit pheromones on their way, and then gradually what will happen that the shorter sides, ants will start following the shorter sides because the shorter side would have higher density of pheromone. And this is what this ants, if you can see here also, there's a shorter side. By the time one ant moves one side, the other ant is only halfway around, and then suddenly more ants move, and by the time there are four ants may have moved, and suddenly you will find high density of pheromone on the shortest path, and gradually all ants will start moving on a shorter path. Now, this inspiration, the foraging behavior of ants, has led to algorithms like the ant colony optimization algorithms, where you adapt the behavior of ants in terms of their searching for food to solve problems like what you call the traveling salesman problem. And general ACO, it happens to be a population-based general search techniques for combinatorial problems inspired by the foraging and pheromone trail behavior of real ant colonies. It talks about two models, the pheromone model and stigmergy. Stigmergy, as I said, it is the asynchronous communication, indirect communication that happens through the environment. One ant lays pheromones in the environment, which is noticed by the other ants, which indicates to the other ant that this path may lead to a food source. And this is a parameterized model. So if you see that this parameterized model XY has two aspects to it. One is what you call the pheromone density, that is tau, and there is one is the attractiveness of the path, that is eta. So the density is high. There is another aspect is the attractiveness. Maybe some path may be shorter, some path may be longer, little bit longer, but the longer path may be offering you food, shorter path may not be offering food. There's an attractive component also. So you take both into consideration to compute the probability of the ant K traversing a path XY. So ant has many options to traverse. Every path will have certain probability associated with it. That probability would be computed taking into account the pheromone density in those paths and the attractiveness on this path. And accordingly, the probabilities, and you know that it's a stochastic optimization algorithm. You can compute these probabilities, and then accordingly, the ants will traverse a particular path. So it's like saying that, you have this initialization, place each ant in random city. So this is how it moves. Let me show you an example further. So it's like saying all 5 ants are sitting in 5 different cities in a TSP problem. So suppose I assume that all ants are sitting initially as a solution. Suppose I assume the ant at A. Now ant A can move to 4 cities. Either it can move to B, C, it can move to D, it can move to B, it can move to E. Every path has some pheromone density and some attractiveness. And the ants will compute this value, That is probability that the ant will move in the path I and j. The kth ant moves in the path I and j, and this is computed based on the pheromone density in each and every path and the attractiveness of each and every path. Based in this, your probability, the ant will decide which path to move. And suppose assuming that the ants move this path based on the probability measure. So similarly, ants will have now the path AD. So it's a constructive based algorithm where the paths, the order of cities are constructively made. So similarly, other ants will also compute the cities, and you have 5 solutions. Each ants, depending upon where they have started from. And you have 5 solutions, each solution has a length. That is the amount of distance being traversed in each and every path. And then given the length of these ants, you store the length, which is the minimum length, and then you actually store the pheromone, the pheromone in each length. So it's like saying that, you deposit the pheromone in each length. So you update the pheromone density. Because all the paths suppose the paths where all the 5 ants have traversed will have higher pheromone density, because more pheromone density will be deposited on the path because all the 5 ants have traversed. There may be paths which no ants may have traversed. In that case, that path will not have any updation of the pheromone density. So after every iteration, you update the pheromone density in each and every path, and then gradually what you do is, then you construct the model again, you do it, the new ants are born, and again the process repeats. Till for a given number of iterations, you keep repeating the process, and then after a given defined number of iterations, you understand which path has actually the minimum distance that is traversed. Now, this inspiration from ants' behavior in real world in terms of foraging food and has led to algorithms like ant colony optimization that can solve computational problems, complex problems like the traveling salesman problem. So this condition can be stagnation or the maximum number of iteration. It's very interesting aspect of bees. Bees is something which we recognize by the fact when they sting you, so you have some sort of a swelling in your hand or someplace. But you don't understand, bees have very interesting and intelligent characteristics bees have. Now, bees have, bees usually stay in a honeycomb. So honeycomb has, if you see a honeycomb from outside, it has a very interesting structure of a, hexagonal structure. Bees knew far before, even if the network community knew that the hexagonal happens to be the most stable structure. Bees knew it far before, and that's why they have constructed their honeycombs with those cells which has a hexagonal structure. Now, inside a honeycomb, there is a dance floor. And the bees actually wander around, look for flowers so that they can bring nectar from those flowers. They wander around looking for such flowers, and once they find such flowers, they come back to the honeycomb. What they do after coming back to the honeycomb is there's a dance floor where bees are surrounding the dance floor to look at those bees which come after searching for flowers. They come and perform dances on the dance floor. Some bees are more vigorous in their dancing, and some bees are less vigorous. So the ones which are less vigorous actually leave the dance floor and become like other bees who are watching the dances. The ones which are vigorous are the ones who have found a good food source. Their dance is a reflection. They actually usually perform 2 types of dances, maybe the round dance and the waggle dance. The dance is a reflection of the fact that, it gives you the direction of the food source, it may give you the quality and the quantity of the food source. The other bees actually watch these dances and decide which bee to follow to the food source. So it's like a recruitment process. The bees dance to recruit other bees to the food source. And gradually what will happen that the other bees will go along with that bee to the respective food source to bring nectar. And that is how the honey gets created in a honeycomb. Now, this is a very interesting of bees. It's again a foraging behavior of bees where they look for food. That is the foraging behavior of bees. And that led to algorithms like the bee colony optimization. There's another interesting behavior of bees that happens to be the bee mating behavior. Now, if you see a honeycomb, in a honeycomb, there is only one queen bee. One queen bee, there is only one queen bee. Queen bees are much bigger in size compared to other bees. There are worker bees, which are sterile female bees, which looks care of the broods. And there are, drones, that is the male bees that are actually saving the queen. So whenever you attack, actually, the bees have very unlike nature like humans. Whenever you attack the honeycomb, the bees come after you. Which are these bees? They are the drone. These happens to be the male bees. They actually come after because they find that there is a threat to the queen, and they attack you and they sting you. And the interesting nature is, when they sting you, they immediately die after that. So interestingly, they sacrifice their life for the queen. The idea is to save the queen. There's only one queen bee. Now the queen bee, after some time, they mate with the drones in a drone congregate area, and they produce broods. Some of these broods are fed with royal jelly. It is possible that all of these broods which are fed with royal jelly turn out to be the new queen bees. If there are more than one queen bee that comes out of it, then they fight with each other. At the end, there is only one queen bee left, a small brood queen bee. And there are more than, if there is only one there, it just comes there, and suddenly what happens is the old queen bee, with half of the population of the honeycomb, shifts, leaves the honeycomb for the new queen bee, and sets up that honeycomb somewhere else. So this behavior, so that's why sometimes after maybe 5 or 6 months, you find another honeycomb getting built near the honeycomb. So that is, the old queen bee has left the honeycomb along with the worker bees and the drone bees, and set up another honeycomb nearby. Now, this mating behavior of queen bee with the drones to produce queen bee, which happens to be much better, which is much larger in size, which is there, has led to algorithms like the bee mating optimization algorithm. Now, why this is that queens are the best solutions, and every time you keep making the queens, and these queens actually at the end, for a given number of iterations, you run this algorithm and you find the best possible queens. So I will talk about the foraging optimization algorithm when you talk about bees in nature. As I said, bees in nature, a bee is a social and domestic insect. There are 60,000 to 80,000 bees in a hive. Bee behavior, bee performs two kinds of behavior, either the foraging behavior or marriage or the mating behavior. Bees in nature look for food by exploring fields from the neighborhood of the hive. They collect and accumulate food for later use for other bees. The bees feed on nectar as a source of energy and pollen as a source of protein. Bee communication, the bee communicates with the help of dances, which are used to communicate information about the food source. As I said, they perform two types of dances, namely the waggle dance and the round dance. There are three terms are important in case of bees foraging behavior. The food sources, the value of food source depends on many factors such as its distance and its direction from the nest, quality and quantity of the food source. Employed foragers, they are associated with a particular food source which they are currently exploiting and or are exploited at. They carry information about this source, its distance and direction from the nest. There are unemployed foragers. They are continually at look for food source to exploit. They are called scouts or onlooker bees. Scouts are which are wanderers who go around for looking for food source. Onlooker bees are one which are waiting for bees to come and perform their dances. They search for food source around the nest. Onlooker, they wait in the nest to share with the employers. And you can see that bees comes to the honeycomb and perform their dances. A hive contains a large number of bees and nectar. After delivering the food in the nest, the bees do one of the following. It's either abandon the food source and become unemployed and become the onlooker bees, or continue to forage at food source without recruiting the nest mates, dance and recruit nest mates before they return to the food source. And that is why they perform those dances, which happens to be round and waggle dance. And they, by performing these dances, the idea is to recruit other bees who are onlooker bees and take them along with them, take them along with them to the food source, the flowers. Artificial bee represents an agent of limited memory. The idea was to create multi-agents in the system. Every engine generates one solution to the problem. The artificial bee are made of three kinds of calling agents: the committed bee, the uncommitted bee, and the scout bees. So this has led to something called what Lucic and Tendrick came into a concept of bee colony optimization, which happens to be again a constructive algorithm. It's like for a case where you have cities and there is a traveling salesman, and each of these values are the distance between the cities. So just try to depict it through some sort of a graphical representation. You can just see H is a honeycomb, A, B, C, D, and E are cities. Suppose there are three bees which are start from the honeycomb. One bee starts from A, the other bee starts from C, the third bee starts from E, and then constructively makes the direction. So it's a permutation problem. Every bee moving from, as I said, some sort of probability is computed from moving from one city to all other cities. So there are four possibilities, and it's a stochastic optimization algorithm. So accordingly, the bee decide which direction to move. So A moves to B, the bee at A moves to city B, and maybe the bee at C moves to city A, and then bee at E moves to city C. So this is how the solution of a traveling salesman problem will get constructed. So this is how you construct a solution. And then after something, they will come back to the honeycomb, they'll perform their dances, and they will recruit bees. Some of these bees will become now followers of other bee. They will stop foraging, they will follow the other bee, and that's what happens gradually. So if you see this, next time this the A and B becomes B2 starts following B1, and that means it does not find a food source, good food source early, so it becomes now follower of B1. So it will follow B1 till the last stage with where they were there, and then this will go on till they move to there, and after this was the last stage, and then after this they might diverge, and then B1 will take its own direction, B2 will take its own direction, and this is how the solutions will get constructed. So what happens is every stage you move a certain level and then come back to the honeycomb to discuss your solutions. And this is what happens. And you have one result of first iteration is one traversal, which happens to be the permutation path that starts from the source city to the destination city. And that is how this city traversal takes place. So then you can find the total length. In this case happens to be 375 units. So this is how you keep iterating over a period of time. The bees travel, keep the paths gets constructed again and again, and that is how you keep updating those paths. And you have results of the second iteration. Maybe the number of distance may have improved. So the second iteration that becomes 375 units. So there are various such algorithms which helps in defining such problems. And we have already talked about the bee colony optimization, the honeybee mating optimization. We have talked about another algorithm which we should be inspired is the particle sum optimization. Now this happens. This is an inspiration from a flock of birds. When you see birds in the sky, they are actually flying in a V shape, and there is one bird which is leading the entire flock of birds. Then how? And but unlike in the case of ants, where the communication happens to be asynchronous through the environment, these birds are actually interacting while they are flying on the sky. So they are interacting with each other while they are flying in the sky. So what they are sharing is they are also looking for a food source or a place of rest. While flying, they are sharing the food source, the best food source they have found, or a place of rest they have found. And once and then they start computing which of them have found the best such food source or a place of rest. And that birds now starts the flock of birds, leads to flock of birds. Now, so this inspiration of the birds sharing together information in a synchronous manner happening at the same time and finding the best place of rest or food has led to algorithms like particle swarm optimization, which are inspired by such behavior. The algorithms like cuckoo search algorithm, you know, cuckoos which are actually have a very melodious sound, but they have one very bad behavior, that is the brooding behavior. Cuckoos never have their own nest. They usually lay eggs in the crow's nest, but they try to identify those nests where they would lay egg, where their egg's texture resembles the egg of the host bird. So the texture of the host bird egg resembles the egg of the cuckoo's egg, and that is where they lay their eggs. And so that the host bird is not able to distinguish its egg from the cuckoo's egg. And that is how the laying procedure of cuckoo is. So it looks for those nests where they can lay egg so that the host bird is not able to distinguish its egg from the cuckoo's egg. Another very interesting behavior of cuckoo is that their eggs hatch faster. So that means their egg hatch faster means that their egg, the small cuckoos are born, and the first thing after they are born, they throw out the host bird's egg outside the nest. That is the brooding behavior. Not only that, they have the ability to mimic the sound of the host bird so that they have larger share of the food source. Now, this interesting behavior of cuckoo searching for nest to lay their eggs so that their eggs are not distinguishable by the host bird, and that has led to algorithms like the cuckoo search algorithm. The algorithms like the bacterial foraging, you know, how bacteria forages for food. And similarly, there are algorithms like the artificial immune system, which is based on a human immune system, where you talk about antigens whenever you get diseases and how antibodies gets created once the antigens are there. And that is how, you know, so all these behavior, whether they are behavior that are inspired by the evolutionary algorithms, that inspired by the swarm behavior, that is by creatures in nature, or by the biological aspect, has been very useful and been used by the computer science community to solve complex problems like the traveling salesman problem. So nature has its own inspiration, nature has its own intelligence, which is sometimes was left unnoticed. Now people are using this intelligence, the ability of the nature and things in creatures in nature, how they have optimized solutions in nature, and how that optimized can be simulated into computational intelligence that can help solve complex problem in computer science for which there exists no algorithms that can give you the best solution. So summary, there was a great interest between researchers and its algorithms at a near optimal solutions in reasonable time. These algorithms are such algorithms capable of the algorithm could be considered belong to classical intelligent optimization tools. Thank you. I would like to discuss on this because most of the people who are doing research are come across such problems which are much more difficult to solve. And such algorithms and hybridized nature of such algorithms have been widely used to solve such problems. There have been, as I said, I would discuss the other aspect also. There has been multi-objective optimization problems. There's something called Pareto Optimality that comes into picture. Now, Pareto Optimality is very interesting concept. When you have these multi-objective optimization problem, there is no way you can say you have to look for solutions which are non-dominated. How can I call a solution to be non-dominated? I can call a solution to be non-dominated if there are multiple solutions. For example, somebody is good in maths, somebody is good in physics, and somebody is good in biology. Now, if and the person who good in maths is not good in physics and biology, and somebody who's good in biology is not good in maths and physics, and somebody is good in physics is not good in maths and biology. Now, if I want a candidate who is good in all the three, then I have these three people there. Can I say one is better than the other? No. So such solutions are non-dominated. Why? Because somebody who's good in maths is not better than others, because the others, one person is good in biology and one person is good in physics. So you cannot compare these solutions because they are dominating. They are solutions which are non-dominated with respect to each other. So when you talk about algorithms like Pareto optimization based algorithm, multi-objective algorithms, you're looking for solutions which are non-dominated with respect to each other. Jyoti Patil, can you mute yourself? So you're looking for solutions that
Sir,
are
I wanted to ask one question, sir. Can you allow me?
Let me finish first, then you ask.
Okay.
So you're looking for solutions that are non-dominated with respect to each other. And that is where you look for, Pareto optimal. For example, I was taking an example of the car. When somebody wants to buy a car, he always look for something like, it should be less costly and at the same time should have more comfort. So if you try to see, you improve on the comfort, the cost increases. So actually improving one objective, that is improving the comfort, the other objective deteriorates. Why it deteriorates? Because I was supposed to decrease the cost, but the cost increased. Similarly, if I try to decrease the cost, that means improving cost objective, but the comfort decreases. So I'm improving one objective, I'm always leading to decrease in the other objective. So what I'm trying to say is that there will be a trade-off solutions in such scenario. So we are looking for a trade-off with a good acceptable level of cost and acceptable level of comfort. Now such algorithms have been solved using Pareto optimization algorithms like the algorithms which are there for multi-objective evolutionary algorithms. Even you have multi-objective swarm algorithms. You have multi-objective ant colony, multi-objective bee colony. So you have the multi-objective versions of such algorithms. But these algorithms are all about finding the Pareto optimal solutions, which has the Pareto optimal front, which has solutions which are non-dominated with respect to each other. So when I talk about solutions in the context of a multi-objective, I'm looking for solutions which are non-dominated with respect to each other. When I say solutions are non-dominated with respect to each other, I mean to say that you cannot say one solution is better than the other. So we are always looking for such solutions. So that is where multi-objective, because I said in the beginning that most of the problems in real life are multi-objective problems. They are not single objective problems. Single objective problems are not there in real life. In real life, whenever we want to do something, we have 3-4 objectives to address. Some are to minimize, some may be to maximize. But how do you, and you're always looking for a trade-off solutions which are which are good and acceptable in all these levels, and that is what we are looking forward to. And that is what is our aim. That is what we look for. So this area has been widely used for solving many problems, because most of the algorithms in real, most of the problems in real life cannot find any algorithm, deterministic algorithm, that can computationally solve and get a best solution in polynomial time. So then that does not mean we don't find a solution. We still find a solution, but such algorithms have been very useful in finding good solutions to such problem, if not the best. Though the solutions they find are, they don't guarantee that they are best, but definitely if they try to improve or find a good set of solutions to the problem. Okay, Jyoti, you can ask now.
First of all, sir, your information is given is very much informative and essential one, sir. Thanks for the best lecture you have delivered to us, sir. My question to you is that whatever algorithm you have explained just now, how the scientist discover that, and if for problem is this one, and this algorithm is useful for this problem, how that can be decided. And second thing is, one algorithm can be useful for particular way, or it can be used for as lot of systems. Can you please answer, sir?
People have worked on the animals and creatures, try to understand the biology of behind them, and try to understand and imitate that biological behavior of animals and the way they optimized and coined these algorithms. One is that. Secondly, you have to, as I said, there are two types of problems which we encounter. One is a P class of problem for which we can find a best solution in real time. And there is another class of problem for which we cannot. There are many such problems. Even an ADDSACT problem is a combination problem which is there. We cannot find solutions in real time. We cannot find the best solution in real time. Then what do we do? Do we say that we don't want a solution? We still want a solution, but if not the best, we're looking for a good set of solutions. I've given an example of a traveling salesman problem because it's a permutation problem with n factorial complexity. Because if there are n cities, there are n factorial solutions. So you will also, in research community, you will also find many problems for which there are many solutions. And there is no way you can explore and exploit those solutions. So one thing is to find a good subset of those solutions. And the way is to, as I said, there are two ways to do it. Either you do a heuristic way, which may not give you a good set of solutions. The other way is a meta-heuristic way, where you incorporate randomization to a heuristic-based solutions. In that case, there's a possibility that you get a good set of solutions to a problem that is there. And all these, one algorithm can solve many problems. That depends upon the type of problem. There are certain algorithms which are developed for continuous optimization problems. There are certain algorithms which are meant for discrete optimization problems. When you do some sort of a numerical optimization, they are mainly continuous optimization problems. So there are certain algorithms which were initially developed for continuous optimization problem, like the particles form optimization. And the problems which we talk about, the traveling salesman problem, they are called discrete optimization problems, and problems like this ant colony were developed for this. So first you can understand what the problem is, whether it comes under discrete or whether it comes under continuous, and accordingly use the algorithms based on the type of problems you are having. Further, sometimes you use an algorithm to solve a certain type of problem with a certain tuning of parameters. But the same set of parameter values may not hold true for the other algorithm. Then you have to tune your parameters, same parameters for other algorithm to get a good set of solution. Another thing which I want to say is there's something called no free lunch theorem. It says that you cannot say one algorithm is better than the other. On an average, all algorithms perform equally good. It totally depends upon the problem, how the data that you have, which algorithm actually performs better. So one cannot claim one is better than the other, but only thing is you need to understand the research, how people have done. You have to find all similar problems and what type of algorithms have been used to solve those problems, and accordingly use those algorithms for solving your problems. So again, I said, first is discrete and continuous, and then within them also you have to see that which algorithms have been used to solve such similar problems which you are going to solve. So that is my answer here.
Sir, and please, another question is my mind that suppose some research scientist discover one new algorithm is there.
Yes,
Then
yes.
algorithm, yeah, for the systems problem. Then it is it
Yes, is it?
is it that approved by some world organization, sir?
No,
Is
no,
there anything?
no, no.
Then how
What you
it
need to
can be
what you need to do
implemented?
is, people who are coming out with this new algorithm, what they do is they use benchmark problems, and TSP is one of the benchmark problems. So what they will do is, they will come out with a new algorithm, and then what they will do is they will apply the algorithm to the TSP problem and apply other existing algorithm to TSP problem and compare and publish the research. So if the comparisons are satisfactory and publish the research survey, then people can use those algorithms as well. But they need to convince the research community that this algorithms seems to gives a better solution to a particular type of problem which others are unable to do so. So that is how people compare and make the algorithms visible to other research community.
They are not belonging to a particular algorithm is not belonging to particular person, not like that, sir.
No, it's a research
It
paper.
is over.
Algorithms, they come out with algorithm and publish as research work. So
Okay,
it's
sir. No, so it is word. It's belonging to all over the
it is
world, sir. Not
it is like a research paper which can be used by any researcher.
okay. Okay. Thank you, sir, for the good answer, sir. Thank you very much, sir.
Thank you. Anybody wants to ask? Lalita, your audio is on. Do you want to ask anything? Lalita Bharathi. Anybody else who wants to ask any questions?
Sir, I'm Lalita. Now it is audible, sir.
Uh-huh.
So, say about data science. What are the difficulties and how to handle it? And
No, that is the challenge.
yeah,
How to handle it is a challenge because of the nature of the data. The nature
okay,
of the data has evolved not only in terms of size and volume, but in terms of heterogeneity and the speed in which it is getting generated. So, things becomes obsolete now faster because new data arrives, which shows a new trend, and the past data becomes irrelevant. Okay, so trends keep changing, and they are reflected through the data. But if you stick to one sort of model for one sort of data, then the model may become obsolete. So you need to keep evolving, recomputing the model based on the new data as well, so that you keep pace with the trends of changing trends in the data also. So this becomes a challenge because this has to be done in real time. You cannot wait. You need to do it in real time on the streaming data that is continuously getting generated. This data itself is very complex because it is heterogeneous in nature and it is voluminous. And secondly, you need to identify from this streaming data which is trustworthy also. So there are so many challenges, so much complexity is there in terms of volume, variety, velocity, veracity. So there are so many things.
okay. So, how it is related to agriculture?
Agriculture also has a lot of data because you have these plant diseases also will be there, which may be used using the imagery data will be there. So if you want a crop yield, the soil erosion, all these things are very relevant because you can have this imagery data and keep working on it. Suppose some farmer is sitting in some agricultural land and he takes a small photograph and keeps pasting it, and then the model keeps computing what is the situation of the crop or the land. That can be of great help. And even if you put a sensor device in a farm, and the sensor device keeps generating this data, and this keeps reporting, and this getting generated and kept in a repository, and there is a model which keeps monitoring it, analyzing it, and suddenly if there is something alarming, the model will reflect, and suddenly preventive and proactive measures will be taken to address any disease in the crop or any degradation of the soil. Is it fine?
Thank you so much, sir. Thank you for your informative message. Thank you.
Anybody else? Anybody else? Anybody else wants to ask? Gandhiya ji, you just changed the second topic. You just changed nature-inspired computational intelligence, which I have given. Okay.
Yes, Professor. Yes, Professor.
Okay.
Students or research scholar any regarding to based on queries or doubts, any doing the project, current projects, relevant related examples, to ask with discuss with professor.
You can ask. I'm there to discuss with you. You can ask.
In our PG students, UG students, both are engineering and science disciplines.
If anybody wants to ask, they can ask.
Sir, can you please share your mail ID? Because I wanted to make you as a guest lecture for our students.
I will share getting the period permission from sir. After I will send it, madam.
Okay, okay, sir.
Okay.
I don't want to miss such type of eminent
Yes, ma'am.
person.
First of all, I concurrence with the professor. After I will send it, ma'am. Okay, ma'am.
Okay, okay.
Definitely, ma'am. Okay. I think lot of faculties there, government, private faculties, and also faculties doing PhD. So, lot of courses is there. Current discuss with professor. This
Can you
professor
see
is
my
a
email
very
ID now?
professor. I will send it, professor.
Yeah, I have shared it in the chat also.
Okay, okay,
Yes, sir,
professor.
yes,
Okay,
sir.
okay, professor.
tvvijaykumar@hotmail.com. Okay. Any more questions? So I think in that case, best wishes to all of you, and hope to see you again some other time. And keep working hard at this time. And best wishes. Be safe. Take care of yourself. Thank you.
Any queries? Otherwise, formally, thanks to what of any queries discussed with professor. Otherwise, Madan.
சொல்லுங்கண்ணா.
அந்த ஃபீட்பேக் ஃபார்ம் செக் பண்ணிட்டீங்களா?
இல்லைங்க, இன்னும் பண்ணலைங்க. பண்ணிடுறேங்க.
செக் பண்ணுங்க. செக் பண்ணி சொல்லுங்க, அப்புறம் போஸ்ட் பண்ணிடலாங்க. ஓகேங்களாங்க?
சரி.
ஓகே. சித்ராம்மா, சித்ராங்கம்மா,
சொல்லுங்க சார்.
நீங்களே ஃபில் பண்ணுங்க. செக் பண்ணிட்டு சொல்லுங்க ஏதாவது பக்ஸ் இருக்கா. ஓகேனா போஸ்ட் பண்ணிடலாங்க.
ஃபீட்பேக் லிங்க்
உங்களுக்கு வாட்ஸ்அப் பண்ணி பாருங்க. உங்களுக்கு
ஓகே காந்தியஜி.
ஓகேங்க சார்.
ப்ரொஃபசர்,
அது வாட்ஸ்அப் பண்ணிட்டு
ப்ரொஃபசர், thank you for given the first of all, thanks to accepting my invitations. The given for your busy schedule. I know for your busy also professor different of disciplines, and also you very busy schedule of know very well. And also recently do the lot of project meeting last week. Every time I call up you busy meeting and switch off your phone. The very busy of time, professor. And wonderful lecture of nice lecture. Thank you for once again coming and given the 2 sessions of lectures, different portions, very informative sessions.
Okay, thank you, Gandhiyaji. Thank you.
Thank you, professor. Thank you very much, professor.
Take care. And so, thank you very much. Best wishes to all of you. Thank you very much.
Thank you, professor. Thank you, professor.
Sir, feedback link, please.
So
No, I will check it. I will check in. Immediately post. A few minutes, few seconds, we will post.
Okay, Gandhiyaji, then will have interaction with you later. Thank you very much. So I will then leave the meeting. Thank you.
Thank you, Professor. Thank you very much, Professor.
Sir, feedback link in WhatsApp you are posting?
Ma'am, few minutes wait, ma'am. We will checking any bugs is a few minutes post. Will post. Few minutes, ma'am.
So in sir, you can post in WhatsApp and all that one, sir, instead of chat box, sir.
No problem. That is lot of some people, some faculties discuss with some queries. Is people is registered but is not participating in the program. That is very difficult. I will post the
Sir, you can check it.
Google.
No, you can you can check it with the computer. No, who is attended, who is participating on
That
all
is
these things, sir.
I know that is defaulting attendance is there. We were add on to default attendance and the defaulting starting time to from
Sir, sir, we
Madan.
are having this.
Madan,
ஆனா இன்னும் வரலண்ணா எனக்கு. மறுபடியும் ரீபோஸ்ட்
WhatsApp
பண்ணணும்.
பாருங்க.
வாட்ஸ்அப்பில் வரலண்ணா. அந்த லிங்க் தான் வந்திருக்குங்க. ஃபீட்பேக் லிங்க் வரலைங்க. இந்த கூகுள் மீட் லிங்க் தான் வந்திருக்குங்க.
Then you post in WhatsApp, sir, or some that is otherwise. It is better, sir, and you check.
In mail also we can send, sir. You can fill.
That is better, sir. In mails and all these things. Then people will not be get the advantages of yours, sir. Sir, shall we leave? We will please post on a telegram then, sir. Your group is there, sir. Shall we leave, sir, meeting? Or we have to wait for feedback link, sir.
Ma'am, wait some time, ma'am. We are
Madam, I
sending
posted, ma'am. Already posted a feedback link, ma'am. Check it the chat box. மதன் வந்துருச்சுங்களாங்க? chat boxல வந்திருக்குங்களாங்க?
வந்திருக்குங்க.
Sir, in feedback link
வந்திருக்குங்களா? chat boxல வந்திருக்கு. We are receiving chat box link. Sir, ஆனா டேட் வந்து 13 இருக்குண்ணா.
ஓகே, அது நோ ப்ராப்ளம்.
ஓகே.
So date on feedback link is 13th of February, not 14th
okay,
of
no
April.
problem. Again, I post. Participants tomorrow session for Monday to Friday 2 to 5 evening session.